Hello friends, welcome to engineering tutorial. Now in the previous video we discussed about boolean expressions, the basic concept about boolean variables, boolean terms, boolean expressions, and the standard or canonical representation of the boolean expression, that is the sum of products and the product of some form, or the min terms and max terms. In today's video we are going to discuss about the concept of min terms or the SOP in detail. First we'll discuss about min terms and then we'll discuss about SOP. Okay. First of all, let us understand what a min term actually is. Let us say we have three variables, boolean variables available to us, A, B and C. Okay, now look at these terms that I am forming. Okay, in all of these terms, the variables that are involved, they are multiplied together, or as they say in digital logic, they are ANDed together. Okay, the variables are ANDed together. So a min term is a boolean term which consists of one or more boolean variables multiplied or ANDed together. That is what a min term is. Okay, this is a min term. Now some more concepts. Okay, in a min term, okay, whenever you look at a min term, the complemented variables, okay, let's say we have a variable A, the complemented variables, let's say A bar, it represents logic 0, and the uncomplemented variables or the normal variables without any bar above them, let's say only A, they are logic 1, they represent logic 1. So this complemented variables, they represent logic 0 or low state, and the uncomplemented variables, they represent a logic 1 or high state. Okay, suppose I write A, B, C. What it actually means is 1, 1, 1. Okay, in binary. In decimal, it is what? 7. Okay, similarly, if I write A complement, B complement, C complement, what it actually represents is 0, 0, 0 in binary, and in decimal it is 0. Suppose I write A bar, B bar, C. What it actually means is 0, 0, 1 in binary, and in decimal it is decimal number 1. Okay. So this is what I am trying to say. Each complemented variable in a boolean term represents logic 0 or low. Each uncomplemented variable in a boolean term represents logic 1 or high states. Okay. Now the boolean terms, okay, the minterms or the product terms or minterms, they are represented by the symbol small m subscript I. What I am trying to say is that, let's say we have again the three boolean variables a bar, b bar, c bar. What they mean? It is 0, 0, 0 in binary and 0 in decimal. So they will be represented by this symbol, this term m subscript 0. Similarly, a bar, b bar, c, it is 0, 0, 1 in binary and it is 1 in decimal. So this will be m small m subscript 1. Similarly, a bar, b, c bar, it will be 0, 1, 0. What this actually is? Decimal 2. This will be represented as m2. Similarly, a bar, b, c, this will be in binary 0, 1, 1 in binary and 3 in decimal. This will be m small m subscript 3. And similarly, if we go on, keep on going downward and we continue up to a, b, c, this will be 1, 1, 1 in binary. This will be decimal 7. This will be m small m subscript 7. Okay. This is the way what the small m subscript I, it means minterms. They are represented by this symbol. Okay. Now the SOP expression is formed by the group of these minterms that are added together, the sum of minterms. It gives us the SOP expression. Okay.